Okay. Okay, good. Thank you so much for having me. I'm super excited to be here and to talk with you about what we learned from reading 100 plus Kubernetes Post-Mortems. But before we begin, I would like to introduce myself. So my name is Noaa Barki. I'm from Tel Aviv, Israel. I've been a full-stack developer for more than 5 years. And as they said before, I'm a tech writer and one of the leaders of GitHub Israel community, which is the largest GitHub community in the whole world. Actually, no, in the whole universe. And I also work at an amazing company called The Tree, where we help developers to prevent Kubernetes misconfigurations from ever reaching to production. Now, you probably read between the lines here, and so you understand that partly my job is to not only understand how Kubernetes work, but also how you can blow up your cluster. Because at The Tree, what we do is policies. This is actually what we do for a living. And especially and personally, my mission was to learn about other companies, how they adopted Kubernetes, and the most fun part, how they failed to do it. So today we are going to talk about top of my Kubernetes failure stories that I've read. We'll do it in a post-mortem way, so we'll talk about the event and what are the lessons that we learned from each event. One really important thing that I want you to take from this session is why policies are so important, and we'll finish it with 3 cool tools that I want you to know so you can use it in order to prevent the next production outage in your organization. And hopefully you won't become one of those Kubernetes failure stories. So let's start with the first story. The first accident happened to Target. They had one failing cron job that created 4,320 pods that were constantly restarting. Not only that it took their cluster down, but also the cluster accumulated a few hundred CPUs during that time. You can only imagine how much it cost to them. Now, why did it happen? The reason that it happened is because they use this default cron job configuration. Now, if you take a closer look, you'll see that the concurrency policy by default is set to allow, which means that whenever the cron job gets failed, the next job doesn't replace the previous one. And that led Target to this incident. So what is the lessons that we learned from Target is to always make sure that and verify that the concurrency policy is set to either forbid or replace. And if you do use the allow configuration, just make sure that you really know what you're doing. The next story is about Zalando. Now, Zalando is an online fashion company with over 6,000 employees. Their incident was also due to a cron job misconfiguration. However, their API server was down due to out-of-memory issues because they used the cron job with this following config. Now, raise your hand if you see the mistake in this config. I don't see much of hands here. And you are correct because this is the correct way to configure your cron job. The incorrect way, or what Zalando did, is that they placed it incorrectly in their Kubernetes manifest. Instead of placing it here, they placed it here. So the concurrency policy wasn't part of the cron job spec. So they ended up having a cron job that didn't have any limits, or that were just spawning bubs that were actually completed, but they were never cleaned up from the API server. So Zalando teaches us that we always need to ensure that our Kubernetes YAML structure is valid. Ideally, we would want to do it through automated checks. And I know that it may sound very basic, but it is actually what happened to Zalando, and it can really happen to anyone. Not all companies are a large organization, but we also have Blue Matador, which is a small startup company. And one day, one of their DevOps engineers noticed some out-of-memory events preceded by high memory usage on their production nodes. So he started to look for the problem, and he first found that the errors came from pods that were third-party application whose containers were memory hogs. He dug a little deeper, and then he found that the requests and limits were not configured on those pods at all. So this practically means that Kubernetes didn't stop those pods from taking up all the memory in the nodes, which led to memory leak and eventually system out of memory errors. So Blue Matador teaches us to always specify the requests and limits. And this is very important policy, especially for third-party and services applications, because you can never know how much memory they will consume. And the last story, which actually my favorite story, because this was the first mistake that Target had when they started to adopt Kubernetes, was that their cluster was down due to ingress misconfigurations. Apparently, one of their developers decided to apply ingress resource with a star on the ingress host. So if you aren't familiar with ingress, when you put a star in your ingress resource, you practically tells Kubernetes to forward all the traffic from all the cluster to that container. So you have one container taking all the ingress traffic of an entire cluster. This pretty immediately took their cluster down just simply because a developer changed that ingress config. And what Target teaches us is to always make sure that you prevent users from specifying the hosts with a wildcard, but also if you do need to use the wildcard, just make sure that you really know what you're doing. But as you can see, most of the accidents and mistakes were pretty innocent, and it's very, very easy to cause production outage when you use Kubernetes. So first, I really encourage every one of you to learn about companies' failures. There's a lot of content about it online. It happened to Google, Spotify, Airbnb, and lots of other companies. But the main reason that I highly recommend you to do it is because this will enforce you to ask yourself a very important question: how you can prevent it in the future, how you can make sure that this would not happen to you and you won't become one of those Kubernetes failure stories. And I asked myself that very own question. So I summed up a few tools that I learned along my journey, so you can use it in order to protect your cluster from having the next future production outage. So today we'll talk about 3 tools. We'll talk about Gatekeeper, Conftest, and my very own beloved, the tree CLI. But before we dive into which one of the tools, I want us to talk about where each one of them is being used in the pipeline. And this is important because I want you to think about where would be the most suitable place for you, because the tool that you will choose and where you will decide to place it may affect your entire organization and how it works. The tree and Conftest, for example, they both take place in the development phase in the pipeline, because both of them are specially designed to be run in the CI or as local testing, or even as a pre-commit hook, just like unit testing libraries. Gatekeeper, on the other hand, will protect your cluster for sure, but it will only take place in the production part of the pipeline. Now, let's talk about Gatekeeper. Gatekeeper is a policy controller for Kubernetes. In more details, it's a customizable admission webhook that enables you to enforce policies executed by an open policy agent. I call it OPA and OPA just as well. So basically, Gatekeeper acts as a bridge between Kubernetes API server and OPA. So it integrates with Kubernetes using the dynamic admission API as a customizable validation admission webhook. The way that Gatekeeper works is very, very simple. On every request that comes into the cluster, Gatekeeper sends the policies and the resources to OPA to check if it violates any particular policy. If it does, Gatekeeper will return the policy error message that you wrote and the resource will be rejected. To use Gatekeeper, all you need to do is first to install it on your cluster and then add a constraint template, which will represent the policy that you want to enforce. Once you created a constraint template, all you need to do is to define constraint that will actually get invoked when you will do kube apply. So for example, here's a constraint. I'm sorry, I'm very nervous. This is a constraint that enforces all the namespace to have gatekeeper label, and it uses the Kubernetes required labels constraint template. This is the actual constraint template that we created. So as you can see here, this is part of the constraint template spec, but this is the actual policy. And because Gatekeeper is built on top of OPA, we need to run that policy, to write that policy in Lego language. But that's it. That's about Gatekeeper. The next tool that I want us to talk about is conftest. And conftest help us write tests against any structured file. And just like I said before, it is specially designed to be run in the CI or as a local testing. You can practically think about conftest as a unit testing library for your Kubernetes resources. Now, under the hood, conftest is built on top of OPA, so all the policies you write should be written in Lego. And something pretty cool about conftest is that it provides the ability to push and pull policies from any OCI and Docker registries. The way that conftest works is also very, very simple. All you need to do is to install it, define the policies and the error messages, and then run the conftest test command with the test of the files that you want to test. That's it. Conftest will evaluate all the resources against all your policies. And that's practically it about conftest. And the last tool that I want us to talk about is the tree application. The tree is a CLI solution that, just like conftest, enables you to test policies against YAML files. The difference between the tree and conftest is that the tree comes with built-in policies for all Kubernetes best practices. In addition to that, we also provide a centralized management for all your policies using UI application, things like creating new policies, editing the current policies, reviewing full history of the invocations, and more. And the way that it works is very, very easy to understand. The CLI runs automatic checks for every resource that can pass. And after finish the evaluation for every violation and misconfigurations that we found, the tree will display an output of all the violations with guidelines to how to fix the issues next time. To use the tree, all you need to do is to install it with a simple one-liner command and run the tree test command with the test of the resources that you want to test for. And last but not least, it's an open source project, so it's free. And because I personally wrote it, I really encourage you to review my code, open pull requests, and help me and the rest of my team to make it the best solution for your production. So to sum up, I really want you to remember that sooner or later, Kubernetes will become your holy temple, and you will spend time and resources on embracing it and developing it. The way I see it is that you're not only adapting Kubernetes, you're also changing the culture in your organization. DevOps is not something that happens overnight. It's a process, and you think about how to manage it, especially in scale of terms. And just because Kubernetes allows you to deploy a pod with specific kinds of configuration, it doesn't mean it's a good idea. I hope this will inspire you to start thinking about your policies, how you can define them and manage them in your organization. Thank you so much.